Hi, everyone. Today, we are going to be talking about spectrometers and how to determine which spectrometer is right for you. Like Angie said, my name is Melissa. I'm one of the chemistry staff scientists here at Vernier, and I do a lot of work in product development and just faculty, TA training, technical support. It's a pretty small company, so we wear a lot of hats. And I'm joined here with Noose, and I'll let him say hi and introduce himself.
Hi, my name is Hill and Nüsret Hisim. I was a chemistry teacher in high school in Maryland for 34 years and used Vernier equipment for almost the whole time that I was teaching. And came to Vernier in 2016 and am an education specialist. So workshops, webinars, help writing curriculum, and that's a lot of fun. So coming up with some cool activities for you all, presentations everywhere. Hopefully some of you will be at BCC this year. I'd love to see you there. Also at NSTA. So I'm going to help Melissa. I'm going to man the chat, and if anybody has any questions, throw them in there, and the object here is to answer your questions. If you have any questions about Vernier and spectroscopy, we would love to help answer those.
Good segue, Noose. Thanks. So yeah, this is kind of our first attempt at an Ask Me Anything type series in our webinars. And basically what that means is we're taking questions that you all commonly ask us. If you're new to Vernier, we're really big on customer service and customer support. So we also answer phones. We talk to customers via chat, via email, at conferences. And so we get a lot of the same questions over and over again. And so we're kind of taking some of those and turning them into this Ask Me Anything series. And our first one for it is the top questions that we get asked around spectrometers is Vernier has a ton of different types of spectrometers. And we have like 6 or 7 different spectrometers. So what is the difference between all of those spectrometers? And why are some more expensive than others? Because some are dramatically more expensive than others. And then that leads to the question of which spectrometer is best for me and my applications and the experiments I want to do in my classroom. So we're going to be addressing all of those today. Again, throw your questions in chat at any time during the talk. Noose will be answering those. And then if we have time at the end, we'll let people unmute and we'll have a discussion. But until then, just put them in the chat. Noose will interrupt me. This is not meant to be a lecture. It's meant to be a discussion. So Noose will definitely interrupt me. But just to keep things flowing, please save unmute for the end. All right, so what is the difference between all of Vernier's spectrometers? So there's a couple of key differences between all of the spectrometers. The first one is there are different lamp options for all of our different spectrometers. This results in different wavelength ranges and results in different data collection modes. So absorbance, percent transmittance, fluorescence, emissions, all those things. So the lamp and its configuration determines both those things. And the higher the wavelength range, the more data collection options, then the higher the price tag gets. So that's the first difference. They all have different lamp options. But second, they also have different optics and optical benches and quality of optics. This affects the accuracy, the reproducibility, and the sensitivity that you're going to get for those spectra that you're collecting. And an increase in the optical resolution and quality results in an increase in price. So those are the big differences, but it's also important to keep in mind that even though we have a huge array of spectrometers, they have a lot of things in common. So the first thing is that they can all connect via Bluetooth and USB. If you have a Go Direct spectrometer, now we haven't always sold only Go Direct. So if you already own our spectrometers, they may not connect via Bluetooth and USB. But anything moving forward, we only sell Go Direct versions of spectrometers, so they all connect via Bluetooth and USB. They all will do the exact same set of experiment types. So let me explain this. We commonly get a lot of questions, people wanting to know if the spectrometer will take a full spectrum, if the spectrometer will take absorbance versus concentration data. Yes, yes, and yes, all of the above. All of our spectrometers will collect a full spectrum. So that's whatever you're measuring, typically absorbance or percent transmittance versus wavelength. All of them will give you that. All of them will also give you event-based data. So this is commonly called something like Beer's law or determination of an unknown. You know, anything where you want to measure either absorbance, percent transmittance, fluorescence, even emissions data versus an event such as concentration. All of our spectrometers will do that. And then finally, time-based data collection. So a variable, whatever you're collecting data, absorbance, percent transmittance, et cetera, versus time. So kinetics data, rates of reactions, all that stuff. All of our spectrometers will do that. All of them use the same software, Spectral Analysis, LabQuest 2, LabQuest 3. Some of them will use Logger Pro, but that's a little bit more wishy-washy. So if you have questions about that, let us know. But all of them will use Spectral Analysis, which is free. I'm going to talk about it a little bit later, LabQuest 2 or LabQuest 3. Also, all of them that measure absorbance will measure in the same absorbance range between about 0.1 to 1 absorbance units. And I bring this up because this is another really commonly asked question. It's a common troubleshooting issue that comes up. If you are measuring absorbance values above 1, which remember, that's less than 10% of the light getting through that sample and hitting that detector, you need to be using a much more expensive instrument than Vernier is going to provide. Our accuracy only goes up to 1 absorbance unit. So if you're looking at something that's 1.2, 1.5, it'll give you a reading up to 3. That is not accurate results. Anything above 1, your accuracy is going to go down really quickly. So all of our spectrometers have that range of absorbance, which translates to percent transmittance. So just keep that in mind when you're looking at Vernier spectrometers. They are designed for that window. All right, so now that we know the difference and the similarities, really that leaves you the question of, if you're trying to answer the question, which spectrometer is right for me, it comes down to what experiments do you plan to do with that spectrometer? The first and foremost thing that I want to talk about is a lot of people, I know I was guilty of this as an educator and as a student, everything measuring absorbance is a UV-VIS. Right? Go take this to the UV-VIS, get a spectrum, go do this at the UV-VIS, schedule time with the UV-VIS. Let's all go take a UV-VIS spectrum. Not everything is a UV-VIS and not everything needs to be measured with a UV-VIS. If your sample, if you hold up a sample and it is a color of the rainbow, any color that you can see with your eye, that is a visible absorbing sample and you can use a visible spectrometer and save yourself a ton of money. You do not necessarily need to have a UV-VIS. If your sample is clear and it is not a color of the rainbow and you cannot see any light or any color in it, then you do need a UV-VIS. So just keep that in mind. A lot of people call us up, oh, I have a UV-VIS, what is this? And it's visible only. Then you have to think a little bit more specifically about what chemicals you want to look at. So not only are they a color of the rainbow or clear, but what is the actual chemical? Does it give a meaningful absorbance? Maybe would it be better to look at it with fluorescence? Say, I know I want to look at food coloring samples only. I know I want to look at sports drinks only. I'm doing AP Chem. I got to do that sports drink lab. Then maybe all you need is absorbance and percent transmittance. But say, oh, I also know my biologist uses this spectrometer and they want to look at chlorophyll, and chlorophyll is also really cool for fluorescence. I can use it to teach fluorescence. So some chemicals do lots of different things, and you can get away with, either sharing with chemistry, biology, and physics, or doing it for different applications, doing it for your entry level students or your AP students. So really think about the different chemicals that you have access to that you commonly evaluate throughout the year. And some of them do fluoresce. You may also want to be looking at samples that just emit light, like a gas discharge tube, or you're putting some metal salts in a flame, and you want to take a full spectrum of that. All right. And then lastly, touching on, people will just call up and say, I really just want to get an absorbance measurement at the same wavelength over and over again. That's an event-based data. That's Beer's Law type data collection. Most spectrometers on the market will do all three: a full spectrum, and absorbance versus wavelength, and absorbance versus time. Definitely all of the Vernier spectrometers do. All right, so now that we've kind of touched over everything generic, let's do a deep dive into Vernier spectrometers, what the difference is between all of them, and where their pros are, and where some of them might not fit your application. So the first one about, and for the general spectrometers, I'm going to go order of least expensive to most expensive. And you can find the prices for these on our website. Feel free to just go to the website and check out your price. So the Go-Direct Spectrovis Plus is kind of our entry-level spectrometer. It's previously been called, previous iterations have been called Spectrovis and Spectrovis Plus, and now we have the Go-Direct Spectrovis Plus. This is great for, again, entry-level spectroscopy. It is a visible-only spectrometer. So it goes from 380 to 950 nanometers. So again, if the sample you're looking at is a color in the rainbow, you can measure it with this spectrometer. So it's great for high school, AP, IB, and first-year colleges. Love this spectrometer. It does not only absorbance and percent transmittance, but it also has a really cool feature where it'll do fluorescence, but it only does them at 2 excitation wavelengths. They are fixed wavelengths, 405 and 500 nanometers. So that's great for samples like fluorescein, chlorophyll, kind of some standard ones that high school or lower division college chem are really interested in just teaching the technique of fluorescence. It's definitely not a quantitative fluorescence spectrometer, but it allows you to introduce that concept to your students. And then finally, you can do emissions measurements with it. You do have to purchase a separate fiber optic cable, but that fiber optic cable fits right in the cuvette slot and then turns it into an emissions spectrometer, so you can point at gas discharge tubes and flames and all that good stuff. And lastly, this is the only spectrometer we sell. Even though all of our spectrometers have Bluetooth, this is the only one that has a battery. So it is capable of being fully cordless. So if you do want to take a spectrometer out into the field, you can do that. It is quite small. If you haven't seen it, I'm holding it up here. It's about half the size of my head, maybe. I don't know. But again, because all of our spectrometers have Bluetooth and USB, they'll work with computers, Mac, Windows, Chromebooks, and iPads, iOS, and Android devices.
I do flame tests with this one at OMSI using my phone. I love it. OMSI is the local science museum in Portland, if you're not familiar with it.
Yeah, it's a really cool science museum. And I know Noose is always coming back with really exciting things that he did in the chemistry lab there. And we've done a couple webinars on like the flame test one. We have a whole webinar on that. So I refer to it later in the talk here, but definitely check it out if you're interested in doing flame tests. Okay, so up from that is our Go-Direct visible spectrophotometer. So this is also in the visible only category, so 380 to 950, but it has improved optics and an improved housing. So that allows for that increased accuracy, increased reproducibility, increased sensitivity that you might be wanting in a college classroom or even an AP/IB environment, anywhere where you just need a little bit higher accuracy. It's also in an aluminum housing. So if you do a lot of kinetics experiments and you really are interested in temperature as a variable in kinetics experiments, since it has an aluminum housing, that'll keep the temperature of your samples much more consistent. What else is kind of cool about this spectrometer is that it comes in two pieces. So you just pull it apart, it's magnetic. And you can take the lamp portion off, and this is just the detector part. And if you can see, I know it's really tiny, but you can see there's the little SMA connector opening for a fiber optic cable to go here. So it does emissions a little bit with a little bit better sensitivity, because you're not sticking a fiber optic into a cuvette hole, you're doing a direct connection. So that's a little bit more friendly for emissions as well. But that is the Go Direct Visible Spectrometer. So again, it's kind of looking at all those visible samples, your food coloring, your sports drinks. It only does absorbance, percent transmittance, and emissions. So if you have no interest in fluorescence and you just really want higher accuracy, better temperature control, this is the way to go for those applications.
That thing feels substantial in your hand. I know that.
It's a good one. I'm a big fan of this one. I think it's got a good place, and it is actually brand new. We just came out with it at the beginning of 2022, so it is our newest spectrometer. All right, so now into the real true UV-VIS spectrometers. So now we're going down to 220 nanometers. So these are great for anytime you're trying to do organic chemistry. I know some high schools are really getting into organic chemistry and energy research. So this is a great option for that, but also college, an upper division college chem, biochem, molecular biology. So physical chemistry, instrumental analysis, all those courses where you're looking at clear samples. So things like aspirin, DNA, protein, doing chemical kinetics, so enzyme assays. In fact, one of the free experiments written for this is an MDH assay. So if you commonly use malate dehydrogenase to do your enzyme assays, this will do that for you. It'll give you your 260-280 ratio if you're doing protein purifications, things like this. It also has those better optics, so it still gives you that better accuracy. And but it only does the absorbance, percent transmittance. It will do emissions with that same fiber optic cable. It is worth noting that as you add features to your spectrometer, as you go down into the UV range, as you get better optics, it does, and more lamps or higher level lamp configurations, you do need to put a little bit more effort into your data collection technique and the ways you take data. So this spectrometer specifically comes with 2 quartz cuvettes to help users out. We really want you to be using those quartz cuvettes, especially if you're going below 280 in your range, if you're looking at protein purifications. I know there are plastic UV cuvettes out there on the market. We sell some of them, and those are great for like if you're doing that MDH assay at 340. But if you're going below 280, if you're looking at proteins and DNA, you really need to be using quartz. And I know they're expensive. I know students drop them, but that is just something to be aware of if you're going into the UV-VIS market for your applications. So an extension, and even, this is kind of the next spectrometer that kind of has a little bit of everything we've already discussed. This is our fluorescence UV-VIS spectrophotometer, and this is good for everyone: organic, biochem, molecular bio. It does everything that UV-VIS that we just talked about does, but it adds fluorescence. And it does this with little LED cartridges. So these are LEDs to have your fluorescence excitation. They go in this little slot up here. The fluorescence LEDs included are 375, 450, and 525. We sell several others that you can purchase separately. But this allows you to choose the wavelength of excitation based on your sample. So you can look at a broader range of fluorescent samples like quinine, DAPI, GFP, tryptophan. You can do absorbance and fluorescence all in the same instrument. So looking at Stokes shifts, quantum yield, quenching studies. So this really just has everything that you could want.
Can you get custom LEDs made?
Yes, you can. Yeah, you just need to contact us, call us up, send us an email, and we'll inquire about that. A lot of times we have picked the LEDs we picked because those were ones we could get in a high enough power that you'll get good results with it. So the especially like UV LEDs, they don't have a lot of power and they have a pretty short lifespan. So we've selected the LEDs we sell for a reason. They're ones that you're going to get good results with. Custom LEDs, we kind of have to scour the market. So we try and encourage you to get ones that we already sell for that reason. But if you really need a custom wavelength, we're gonna work hard to help you get that.
And you provide a bunch of experiments, don't you, on the web pages?
Yeah, there's some free experiments for this one as well. So this one has a free experiment looking at kind of all things fluorescence with quinine sulfate. So it's a quantum yield experiment to look at quinine using the 375 nanometer LED. But actually my favorite experiment for this spectrometer is an inquiry-based experiment that I wrote that kind of is designed to remove some of the black box idea of a spectrometer. So students, make up their sample, put it in the spectrometer, hit collect, and then they get this full spectrum. Well, students don't always know what's going into that, especially when it comes to fluorescence or emissions, when you're looking at raw lamps, looking at some of how the optics affect it, how the sample affects it. So it's an inquiry-based lab that has you modify a bunch of things in the software so that students can actually see what I do as a student actually controls the output. I didn't just fill in all the numbers that the lab told me to do, so I got a beautiful spectrum. Like there's a lot of work that goes into getting a beautiful spectrum. So that's definitely on the webpage for this guy. And it also comes with a fluorescence quartz cuvette because it does go down to 220, and fluorescence cuvettes have all four sides clear, so that's also important. Okay, now we're on to our specialty spectrometers. The first one is the emissions spectrometer. This one only does emissions, no absorbance, no percent transmittance, no fluorescence. You don't want to look at any liquid samples. You just want to look at gas discharge tubes, light bulbs, LEDs. You just want to investigate Planck's constant, things like this. You know who you are if you want this. It's great for all levels. And it does emissions great.
Does it come with the fiber?
It does not. So you have to purchase the fiber separately. Okay, so you can use it without the fiber.
Yeah.
For really bright stuff. So if you just want students to go around and point it at light bulbs and things like that, you can usually get good spectra with that. Gas discharge tubes, you'd need the fiber. Like I highly recommend the fiber especially if you're doing gas discharge tubes. But we sell one, but it is a generic fiber. All the specs are on our site, so you probably already have one if you're replacing spectrometers or stuff like that. But they are purchased separately. And lastly, of our specialty spectrometers is the flash photolysis spectrometer. This is for looking at photocatalyzed reactions, so transient absorption. Anytime you need to excite a sample to look at its kinetics. This is pretty much upper division, physical chemistry, instrumental analysis. There's a lot of interest in this spectrometer lately because of energy research. And if you really want to get into the nitty gritty of excited state dynamics of photo switches, this is the instrument for you. It is visible only, and it is the exception to Vernier spectrometers work via Bluetooth and USB. This is USB only, and it is also Windows only. But we made a major upgrade to this one last year, and it comes with a whole set of filters. You can see all the filters, and now it runs off of USB instead of AC power. So that's really nice. Okay, so to kind of recap, if you are in the market for a general use spectrometer, as the price goes up, the capabilities goes up, and the number of samples you get to investigate goes up. So that kind of should help you decide which ones are for you. Because if you're only looking at food coloring, save yourself a bunch of money and get the Spectrovis Plus. But if you know you're going to be looking at aspirin and DNA and all the different things, then you might want to look at the higher end spectrometers. But do keep in mind, with those higher end spectrometers comes more care. You have to deal with cuvettes and solvents and instructing your students in that technique. But then don't forget about specialty spectrometers. If you have a specialty application, those don't quite follow the same rules, but if you need it, you need it. And we have those.
And all of the spectrometers come with cuvettes of one kind or another, right?
Yes, they do. Yeah, the Spectrovis Plus comes with plastic ones. All of them come with either, then everything after that comes with quartz. The visible one comes with plastic. So yeah, they all come with a little starter set. Almost all of them use the Spectral Analysis software. It's free. Some great resources on the website, a user manual, sample experiments, screencasts. Check it out. If you have questions about that, let us know. Again, throw those questions into chat. If you are here because you already know which spectrometer you're using, definitely throw those questions into chat, but we also have some continued learning for spectroscopy on our website. We've done several webinars on spectroscopy. They're all on our website talking about teaching electromagnetic spectrum. That part 2 one is the flame test that Nüs did. It was amazing. Also our biology team just did one on plant pigments, so check that one out. Free experiments we talked about throughout the talk, but flash photolysis also has a whole book associated with it. And we talked a lot about cuvettes. There's some great resources on our website for the differences in all the cuvettes we have. And we've made it to the end here. We have a couple of minutes left. What questions do people have? Feel free to unmute yourself, throw some more questions in the chat. Nüs, has anything come up in the chat?
Saw a comment about flame tests. If you shoot me an email or just shoot chemistry at Vernier, if you look on the screen there, Melissa's got it. I can send you the link to the experiment. The big deal with that, of course, is you don't want the kids to cook the fiber. And believe it or not, you can put that fiber pretty close to the flame if you're careful, and you won't have any trouble with it. And the video that I made shows the setup. So definitely something worth looking at if you want to do flame tests. They come out beautiful. You can do all the unknown and known metals, just the standard flame test, but it is kind of fun to look at like 2 red ones, lithium and strontium, and see how they're similar and how they're different. So yeah. Any other? Yeah. Sorry.
I was just gonna say that flame test webinar is really good because we get questions about that all the time.
Yeah.
And you do really have to work with the settings in the spectrometer software, whichever you're using, Spectral Analysis or LabQuest, to get good emissions data. So definitely check that out if that's something that interests you.
And one of the very common questions is like, I can't get really good hydrogen spectrum, and one of the issues is that like Melissa talked about, the Spectrovis Plus is great, but when you get down there at the low wavelengths for hydrogen, it's challenging. You can fiddle around with the settings and you can improve the spectrum, but the higher end devices tend to look at that low end a little better than the Spectrovis. So if that's an important thing for you, it's something to think about. But you can adjust it. Can UV-VIS spec give the same level of accuracy for emission spectra? Melissa, I'm going to let you answer the one. Question says, can UV-VIS spec give the same level of accuracy for emission spectra of discharge tubes as a specialty spec that is only for discharge tubes? I don't believe that's true, right?
So it's a little bit of a double-edged sword because it does go a little bit lower. The fiber is not a UV fiber, so it doesn't go all the way down, but it goes further down than like the Spectrovis Plus. So with the emission spec, you get down to 350, which gives you that kind of last hydrogen peak a little bit better. And you also get that with the UV-VIS and the fluorescence UV-VIS. I find that the ones that have the SMA connector give a little bit better data in general for emissions than the ones where we put it through a cuvette, the cuvette hole. So does it give the same level of accuracy? It gives better results than the Spectrovis Plus, but it is a continuum. It's like the Spectrovis Plus is probably the worst results you'll get for emission, then the UV-VIS because it still has that cuvette, but it has the lower wavelengths, and then the specialty spec that has the lower wavelength, but it has the direct SMA connection. I mean, which one would I use? So it depends. I mean, I'm a big fan of getting as much bang for your buck as possible. So if you know you're going to be doing UV absorbance data, I would get that one because I know I'm going to get really good results with gas discharge data. And I also know I'm going to be able to use this for my biochem labs, for my organic chem labs. So that's the one I would get. But if you don't plan to share, if you don't need that, if you already have a UV-VIS that does that, and you really just want a really portable emission spectrometer, then get that. So hopefully that helps.
Got an unlimited budget.
Yeah. If you have, get both. I don't know.
Who has that? Nobody has that.
Nobody has that. But yeah, so that's, again, it's such a personal question. Which spectrometer is right for me, you know?
Yeah.
But hopefully this talk helps to really, help you evaluate those questions, because no one has an unlimited budget, and you really got to figure out what works best for your budget and what your classroom needs are. All right. Well, we have reached the end of our time. So thank you all for coming. And yeah, so I think in the follow-up email, Angie will put a link to a Google folder that'll have this slide deck in it, and then some of the links that are in there will be live to the tills and stuff like that. So we'll make sure you get that in your follow-up email. All right. Thank you all for coming. Yep. It was super fun. Give us feedback. Hopefully you like our Ask Me Anything webinar style. Give us feedback. Let us know what other things, what other talks you want.
Next one is in July, right?
Yeah, we're doing the next one for chem is pH, care, and feeding, right?
Oh yeah, that's right. I'm doing that one. Yeah, July 13th. Yep. So pH probes. We got all kinds of questions and answers about pH probes. So that's July 13th. If you're around or available, I'd love to see you again.